Okay, so today we will add another one is conversions of decimal to binary. Vice versa, basically, it is not too hard. And then there will be a new numbering system which is I didn't share, but this one all I guess you already learned in your mathematical. But instead, if you still don't know and this is a new term for you, we will look into the hexadecimal, octal number, and how basically you will like convert between all of them. And then there will be a new, basically very new for you. There will be a new system which is called as BCD, binary coded decimal. Another one is digital code and parity. So you're going to look into several parity in numbering system, and lastly digital system application where you're going to apply all these numbering system. This is like just introduction, and we have so many numbering system that normally in the mathematics we have like positive integer which is greater than 1, and basically we're going to have the base of b, base which is base 2, base 10, base 8, base 16. This is a normal numbering system that you're going to normally use: binary, decimal, octal, and hexadecimal. So here is the example. You're going to see this part, trinary, which is 3, base 3, we rarely use, similar to our quinary. In digital logic and also your mathematical, normally we will use binary, octal, decimal, and hexadecimal. And by using your calculator, you can also do direct conversion, but I didn't suggest you to use your calculator. Instead, please make sure you try to play around and convert manually. Then you will understand basically how to do the conversion. And for base 2, this one I already informed you that it's going to be 2 digit 0 and 1. So you're going to have 0, 1. And for octal, you're going to have 0 until 7. All together will be 8 digit. 1, 2, 3, 4, 5, 6, 7, 8. Altogether 8 digit. So it's called as octal or base 8. And this one is base 10, which is decimal, your normal numbering system that you use in your daily activities. It is like 0, 1, 2, 3 until 8. Altogether is 10 digit. And lastly, we're going to have our hexadecimal, which is base 16. This is slightly different because you're going to have 0 until 8 until 9. This one altogether you will have 10. And supposedly you need to have another 6 digit, right? So another 6 digit, it is not continuous with 11, 12, 13, 14, 15, 16. Instead, the representation will be A, B, C, D, E, F. But the value in decimal will be 11. Wait, 10, 11, 12, 13, 14, 15. This one will be 10. And then 11, 12, 13, 14, 15. So until 15, the value until 15, because you have another value which is 0. So this is if you convert, please try using your calculator, scientific calculator, you convert A to decimal, or maybe decimal to hexadecimal, whether the value is correct or not. Okay, this is just the overview on your numbering system. So I repeat again, we will use for our decimal, our DL subject, which is 2, 8, 10, and 16. Okay. Next is positional numbering system. This one also, like I already shared a little bit, but I don't want you to like very confused with this equation. But mostly, if you add the positives at the left side after your fragments, it will be positive for your base here, the power of 3, power of 1, or the power of 0. And then after your fragment, uh, to the right, it will be negative. So the power series is going to be positive, and here it will be negative. Okay, there is example. Here is your decimal number. Normally, our decimal number, we're not going to write 10 here. Okay, in your test, in your final exam, if it's not showing this best, you need to assume is to be as best 10, because our best 10 normally we use in our daily life. We also not going to show this best, but it is lucky for you if the question directly show that it is best 10, because you might not confuse. Okay, now we have this numbering. What is basically happen? We're not going to do any conversion, but instead we just want to know the positional numbering system, what is basically happen inside all the value. So let's take a look. Last time I already informed you that you're going to have 10 to the power of 0, 10 to the power of 1 to the left, 10 to the power of 2, 1, 2, 3, 4. And to your right, it's going to be negative, positive. So 10 to the power of minus 1, 10 to the power of minus 2. Si I dah ajar matematik pula. So here, siapa yang WhatsApp? Tak sedap pula, email je. Firdaus. Umar. And you're going to place all this number like here, 7, 2, 9, 3, 8, 4. And last time in our previous class, I already give example several times. What you basically will do is you're going to multiple with the numbering above. You're going to 4 times to the power of 3 plus 8 times 10 to the power of 2 plus 3 times 10 to the power of 1 plus 9 times 10 to the power of 0 plus 7 times 10 to the power of minus 1. And lastly, you're going to have 2 times 10 to the power of 2. Okay, so using your calculator now, you're going to get 10 to the power of 3 as 4 times 1000, isn't it? If I mistake, please inform me or correct me. And then plus 8 times 100 plus 3 times 10 plus 9 times 1 plus 7 times with 0.1 plus 2 times 0.01. So equivalent, you're going to get 4,000 plus 800 plus 330 and then 9 altogether. This one you will get 9, 3, add 4. See, that's why you will get this just representation of numbering for 4,839. Basically, this is what is happening. And then for here is 0.7 plus 0.02. And if you add it, you're going to get 7, 2. So this is how basically it's going to be look like. You're going to have 10 to the base 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, 10 to the power of 0. You're going to multiple with the power. And this one 10 to the power of minus 1, 10 to the power of minus 2. So again, you're going to get these looks and similar what I share, and you're going to get the answer. So this is decimal representation and the value, how basically you get. Okay, this is your best number. So whatever best, if let's say 10 is going to be replaced with 10, if best 2 you're going to replace with 2, and normally our best will be more than 1. And your value, you can see this equation, but basically I don't want to make you confused. As long as you understand what I teach previously, you're going to easy get the numbering system done. So this is your integer part and this is your fraction part. And in your fraction part, it's going to be negative, and this one will be positive for your power for your base. And in numbering system, you're going to have most significant bit for your MSB. For your MSB, it's going to have MSB on your left. Nombor paling besar, which is the biggest number, we call as MSB. And sometimes we just ask you in a question, what is the value of MSB? And another one more thing is your LSB. LSB is least significant bit. So your least significant normally on your right. And it is a base 10. Okay. This is a different example. Okay, this one is expression of 47. Decimal, you're going to see similar what I already shows you. On your right, it will be 10 to the power of minus 1, 10 to the power of minus 2, 10 to the power of minus 3. See, please make sure that your 0 will be start on your right. 0, 1, 2, 3, and so on for the positive numbers. And after to your right for your fragment number, you're going to see it started with -1 and so on. And for your 47, you can try the example, and please try to change this value and play around with this step and also the equation. So you're going to see that you have the decimal in value, but in terms of positional value, which is I normally use, which is 10 to the power of 0, 10 to the power of 1. So basically, if you convert it directly, you will get 10 to the power of 0 will be 1, 10 to the power of 1 is 10, 10 to the power of 200, and etc. Here is 0.1, 0.01, 0.001 until the rest. So here there is another example. If you have this kind of value, you can try this example. It's really easy as long as you understand the first example that I showed. I'm not going to do this example or exercise. You can try to do, and please screenshot this solution, because I guess there is no answer in your notes or slide that I'm going to share. Okay, after we done with our decimal, our normal numbering system, which is our base 10, we're going to look into the binary number. And again, we only have 0 and 1, which is we will apply normally in our digital logic, 0, 1, 0, 1. Your computer, although you type A, B, C, D, E, F, until your Z, or whatever you type, saya, house, lapar, food, and everything, uh, they didn't basically understand. Your computer did not understand, but your computer will understand the system with is 010101. So that's why computer were designed with the very basic of gates, and gates is using 0101. Okay, now back to our numbering system. We have base 2 or binary. We will apply only 0, 1 in our representations of numbering. So still, it's going to be similar. Over here, this is a binary weightage, which is if you have value numbering, on your right, you're going to have to the power of minus 1, to the power of minus 2, to the power of minus 3. And to your right, it will be positive, to the power of 0, to the power of 1, to the power of 2, to the power of 3, to the power of 4, until the rest. And if you convert to decimal, the value will be 0 0.5, 0 0.25. This one, I don't know. Maybe you can check. 0 0.75, isn't it? Or over here is 1, 2, 4, 8, 16, 32. And then there is 64, 1 to 8, I guess. Okay, this is your left side. And this one is decimal value if you convert. But in binary representation, you will get this as 1, base 2. This one will be 1, 0. This will be 1, 0, 0. 1, 0, 0, 0. 1, 0, 0, 0, 0. Continue. So why this representation? Because you're going to have your numbering system will be like this. 2 base, 1 base 2. If you have 1 base 2, of course, this one is normally similar to our representation. If let's say you have 1 base 10, 1 base 8, what happened is you're going to have 2 the power of 0, to the power of 10. 10 to the power of 0. 8 to the power of 0. And most of these will be power of 0, you will get 1. Any numbering with the power of 0, you will get 1. So the value over here will be times with 1. So 1 times with 1, you will get 1. 1 times 1, you will get 1. So whatever number here, first you will convert and you get 1 in decimal. So don't want to confuse you. Let's take a look first this. Here is representations of binary. You have 1 base 2. What happened is this one will be to the power of 0. To the power of 0 will be 1. So 1 times 1, you will get 1 in decimal. That's why in decimal value, you get 1. And if you have 1 0, this is not 10 because this one is base 2. You cannot call it as 10. You cannot call it as 100 base 2. 1000 base 2 cannot. You need to mention as 1 0. Although you have 100,000 here, you cannot like say 100,000 base 2 or binary. You need to mention 10000 base 2. So over here, the example for this part, you will get 10 base 2. Over here, it will represent as 0 to the power of 0 to the power of 1. I already mentioned to you it's going to be multiple with the above. To the power of 1, you will get the value of 2. To the power of 0, you will get the value of 1. 0 times 1, you will get 0. 1 times 2, you will get 2. These both number you need to plus. And you will get to the power of 10 decimal. That's why you get 10. So please try to play around with the value and then please check what is your answer for your decimal value. Now I'm going to pick someone. I'm going to give you numbers. Basically, of course, I not going to know the answer. Okay, why don't we have, okay, mathematics normally Chinese student master with mathematics. So I'm going to pick Chinese student. Just now. Xing Yu, can you answer my question?
Yes, total.
Okay. What is the value in, wait what is the value of 1011 base 2 in decimal?
My answer is 10.
10. Okay,
Hmm.
I also don't know. Let's try. Thank you for your answer. Now we have, is it 10?
Uh,
We have 1 over here. Normally, if we have 1, why not get nombor genap?
eh, 11, 11.
Okay, so you, thank you. So over here, you can see you have to the power of 0. You're going to get 1 times with 1, the value will be get 1, plus with 1 times with 2, because to the power of 1 you get 2, you will get 2, plus with 0 times whatever number you will get 0 also, and another 1 to the power of 3 you will get 8. 1 times 8 you will get value of 8. You plus all together you will get 11. Okay, so thank you. Maybe last one person. Tiba-tiba pula masing-masing tunduk Amirul. Amirul Arif dari tadi dah tunduk-tunduk. Amirul, okay. Sekejap I share my screen. Okay, what is the value of I tak nak buat dekat sini. One, 0, 0. Okay, convert it.
My answer is 28.
Lajunya, you guna calculator ke?
No.
Okay, let's try. To the power of 0, to the power of 1, to the power of 2, to the power of 3, to the power of 4. This one is 16, 8, 4, 2, 1. 16 plus 8 plus 4 plus 0 plus 0 equal to 20. Berapa? 25 jawapan you?
28.
28. Okay. Correct. Betul kan kawan-kawan sekalian? So, thank you Amirul. Now, let's go back. After this, I nak cari budak semalam ni. Kejap student semalam dia buat saya pening sikit. Dalam session ni ke? Siapa baru join? Okay, so we're going to continue with our numbering system. I guess you already master binary to decimal. It's very easy. So it's going to be a lot of numbering question also, especially for your test 2. Now let's take a look into this one. Please try to do it, the exercise. Okay, now we go to our octal number. Wait. Okay, now is our octal number. You can see that basically it's also similar. You're going to have 8 to the power of 0, add to the power of 1, add to the power of 2 on your left side. And to your right, it's going to be at to the power of -1, at to the power of -2, and in terms of positioning value. And for your octal octal weightage value, you're going to have 0.01 base 8, 0.01 base 8, 0.1 base 8, 1 base 8, 1 0 base 8, and etc. This one is example for the value. If we are given you with this number, how you're going to convert to the decimal value. And over here, you were given with the octal, and you will do the similar things. What you will do is, we start over here. On our 6, it will be 8 to the power of 0. Add to the power of 0, the value will be 1. So you times with 8 times with 8 to the power of 0. 0. 8 ah? 8 to the power of 0? Is it 1 or 8? I forgot already. See, I already give a wrong info. Anyone? Add to the power of 0 is 1 or 8? Whatever number.
1.
1, right? This one is what? How come this is the way? Okay, it's okay. Forget about this first. So then you will get another one is 0, 8 to the power of 2. Add to the power of 2, you will get, add to the power of 1, you will get 8. And then you have the value of 7. 7, you will multiply with 8 to the power of 2. And then 3, you will get 8 to the power of 3. So over here, add to the power of 1, you will get 8. Add to the power of 2, you will get at plus 8, you will get 64. Add to the power of 3, you will get 512. Okay, now over here, you will like multiple it, multiple, and the value you will plus all together, similar with this. But this one is wrong. This will be 1. And this is on your left side, this value. And now when you go to your right, it also similar. You will have 0 to the power 8 minus 1 and 1, 8 to the power of minus 2. And the value of 8 to the power of minus 1 is 0.125. And 1 times 0.625 for the 8 to the power of minus 2. So after that, you add all together. Oh, all together, you will get the value. So this one, maybe in your module, you need to check and please correct it, the value similar to this part. So please try also the example of your exercise 2.3. Either it's easy for you to convert or not. Basically, it's similar to the previous method. You can try directly. It's not too hard for you. This is the answer. And now let's take a look into hexadecimal number. Hexadecimal will be 16. 16, you're going to have representation with 0 until F. You're going to have also like this number A1, maybe 10, F, maybe FF. So this is can be
It's 9 hours.
in terms of representations of your hexadecimal number. So you're going to convert all these hexadecimal number to decimal number. From decimal, you can change later on to binary or maybe octal, whatever best number later on. It is like too hard for you to direct convert. So that's why you need to slowly step to go to the decimal and then to another best, because our best normally will be decimal. Okay, you can see because it is a best 16, there will be 16 possible symbols. So what it is, it's going to be 0 until 9. This is 10. And A until F, there is another 6. Altogether 16. And as a normal numbering system, you're going to have the best. Not including this one. This will be a normal our daily numbering. So sometimes it's not going to show. But if you convert from hexadecimal to binary, this is all the value. It's already give you directly the value for hexadecimal to the decimal. Okay, now this is like a table, similar from previous. You have the positional value, you have the hexadecimal stage value, and also decimal value. This one you can try also by yourself. And here is our example. If we have A216.D. Okay, let's take a look how we're going to convert it. We have A, 2, 1, C, and then D. This one, we're going to start with 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, 16 to the power of 3. And this one is 16 to the power of minus 1. All of these need to be multiple with the value above. When you multiple it, you're going to get this one. C is 10, 11, 12. 12. This one is 1. 12 multiple with 1. This one is 1. And 16 power of 1 will be 16. So 1 multiple with 16. And then this one is 2. 2 multiple with 16 to the power of 2 will get 2, 5, 6. And A is 10. 16 to the power of 3, the value will be this one. 4096. You're going to multiple. This is how you will do. And at your right side, 16 to the power of minus 1, and D will be 13. This one will be 0.0625. And you multiple. After you multiple all, you will add all this value. There is no answer. Then you will get the answer in decimal. So this is how you convert from hexadecimal to decimal. Later on, you're going to also try decimal to hexa. So same whatever, when you have binary to decimal, you can also have possibility to convert back vice versa decimal to binary. Same with the octal. Just now you already learned how to convert octal to decimal. You need to also know how to convert when you have decimal to octal. Please try to do this exercise. And if you multiple it, you will get the answer. There is also another example. And now, you already learned how to convert from any base to decimal, because you can have to the power of something over here. You can have 4, you can have 3, whatever number you can directly convert to decimal. It's very easy, right? So the summation of the equation is the value of decimal, the one that you do like this. Whatever base of number, you can apply with this method. So please take note, all the example in previous slide are converting into decimal number without total. So you are the one need to calculate the total. Calculate the value in decimal to those example. So here there is another base 5. You can try to play around and convert it. Although as I mentioned, in our in our digital logic class, we're going to focus on 2, 8, 10, 16 only. But in terms of your test and final exam, sometimes it's going to give you different base of numbering, because they just want to know your understanding how to convert from any base to decimal. And sometimes you were given the decimal, you need to convert to another base, referring whatever base they will give. Okay, until this point, is there an equation before we can proceed to another subtopic? If there is no question for your test, I don't want any of you to get wrong in numbering system question, okay? So next I'm going to move. Okay, this one is just a representation. You can try to fill in, and this is the answer if in your like books and also your notes later on there is no answer, so you can fill in by yourself, and this is the correct one. So the solution basically is whatever we already done. It is not too hard for you to know. You can read and go through all of this. It's very easy. There will be ask you to on how basically the step by step for you to get the answer. Okay, after we already done any base to decimal, now we're going to learn vice versa, decimal to another number base. So that,
Miss,
yes?
can we take 5? We need to go to toilet.
Okay, okay.
Okay, thank you.
Okay, well then I'm going to check your friend in WhatsApp. Okay, we continue at 9:15. Take a break first. While I check your friend WhatsApp me. Okay. Okay, shall we start now? Basically it's just 4 minutes, but it's okay. We will continue with our another conversion. I don't like basically if like I need to remember all the terms because I always like okay, as long as I know the method, I know how to convert, I know to like vice versa conversions, then it's okay for me. But you cannot do that. You need to know the term as well, because sometimes in the equation, especially for your part A, it can ask you the method name. So you need to know what is the method name for converting like decimal to another new base. So please make sure also, although you know how to do the conversions, but in terms of all the terms for the method, you need to know also the name, okay? So apply a method of successive division for converting decimal to any number base. What you need to do is first you need to divide for any base to decimal. What you always do is multiply. Now, vice versa, you're going to do divide or divisions. Divide the decimal number by the base of the converted value and get the quotient and remainder. Now you heard about this term, quotient and also reminder. Reminder, I guess, and also quotient, you're going to normally find when you play around with the division. Successive division of the quotient and keep the remainder until the quotient will be 0. The answer is the string of remainder. Read from bottom to up. So there is another hint. You need to read from bottom to up. Now let's take a look what basically all this meaning, because if me myself personally, I'm not the kind of person to understand something from reading sentences. So I need to apply in terms of like doing the technique, then I can understand. But every person have a different characteristic. So maybe maybe some of you are more familiar to understand with sentences, so you can apply and read these sentences. Instead, if let's say you more understand when you play around with the technique, then you need to apply the techniques. So let's take a look the first example. As we know, we're going to learn decimal to any base. So over here, what is the answer? Let's say we have the value. And now for the first example, we will going to convert decimal to octal. So if we want to convert into octal, which is base 8, we need to multiply with 8. So you can see we're going to multiply with 8. So how basically it's going to be look like? So we have 82 base 10, or normally we just call it 82. And we will divide it into with 8. So you're going to see like this. And what is your answer after you divide? You're going to get the value of 1 and then 0. Of course, you're going to have the remainder. So where you going to put your remainder? So you're going to put remainder beside here. Then, of course, over here, you will get another one is 1, right? But slowly you're going to take a look. Okay, this one is you going to multiply again with not multiply, divide again with 8, divide with 8, and you will get the answer as 1. 1 below, and then you will get the same, which is the remainder. So after you divide with 8, what is the remainder? The remainder will be 2. So this is the one that you will get. You cannot divide 1 with 8. Uh, and this is basically how you get the answer, because you cannot have 1 divided to 8 for the last. You're going to show it from 1 2 until 2, another 2, which is from bottom to up. As mentioned in our previous slide, you're going to take and read it from bottom to up. So this is the first example. When you have 82, you're going to divide it in with 8, because you want to convert it into octal. So after, when you divide 82 with 8, you will get 1 0. There is another remainder, which is 2. And then 1 0 divided with 8, you're going to get 1. And there is another remainder, which is 2. And until up here only, then this is your answer of your conversion. Okay, this is our first example. Next, and yeah, it is using successive division. Maybe in your test, maybe in your final exam, is like, what is successive division? So you need to know it is convert decimal to any other base number. Okay. So now we have 42. We want to convert to binary. And we will know that we will use the division. And we will divide with the best number that we want to convert to. So that's why we will divide with the value of 2, because we want in terms of 2. Okay, now let's take a look what is basically happen. Siapa ni? Okay. 42. What are you going to divide with? You're going to divide with 2. What is your answer? 2, 1. Is there any remainder? No, it is 0. And then you're going to divide again. Going to divide with 2. You will get 1 0. And then the remainder will be 1. You divide again, you will get 5. Your remainder, no. And then you will divide again over here 2, and then there is remainder with 1. And after you divide, you will get 1. Over here, there is no remainder. So let's take a look. There is no remainder after that. There is no reminder, so you're going to put 0. So basically similar. So it's like a normal division. So you just divide, and then whether it's have reminder or not, and so on. So you're going to pick your answer from bottom to up. So please play around, go and ask your friend, okay, give me any number. I want to convert to binary. Or maybe give me any number. I want to play around and convert with octal. So if let's say I get the answer, maybe you can also do the similar and we compare the answer who get the correct. But of course, you can like directly check your answer using your calculator. But that one is to check only. To do, please do it manually because you need to learn how to convert it using the successive division, not using your calculator. Okay, now let's take a look into, okay, this one is a table of conversions. You can see what is the representations if you have hexadecimal, octal, binary, decimal. What is the value of decimal and what is the representations on hexadecimal, octal, and binary. This one is very basic thing. Maybe you can like directly remember if A, B, C, D, E, F, what is the value of the decimal. For octal, it will continue until octal. Okay, so it will continue. You can see it will be 1, 1, 1, 2. This one is not 11. This one is not 8. It will continue the numbering. You can see 1, 0, 1, 1, 1, 2, 1, 3. It is not 10, it's not 11, it is not 12. Why after 7 is jump to 10 over here? It is 10? No, it is not 10. Instead, it is 1, 0 base 8. 1, 1 base 8. Because our numbering for octal, it will be total of 8. Then after that, it will continue back. And then we continue back. Over here also, it will be changed like 2, 0, and etc. Okay, now you're going to see this one. Last time we already looked into 10 to octal, 10 to binary, and now we're going to look into 10 to hexadecimal. So here is our hexadecimal. You have 2047 decimal. You want to convert to hexadecimal. Of course, you're going to divide with your 16, which is your hexadecimal value. So from here, you just apply it into this part 047, and then you divide with 16. Of course, I don't know what is the answer over here. If you divide, you can use your calculator for division only, but for the method you need to do it manually. Okay, after you divide, you're going to get 1 to 7. I don't know whether it's get the reminder or not, but if 7 times 3, yeah, of course you're going to have a reminder. So you will get a reminder over here, and this value still can divide with 16. You divide again, what you will get? 7. 7, and then you get the reminder another more times, which is 15 again, and you cannot divide anymore. So this is your final answer. So as you know that this is 16, which is hexadecimal, 15 will be represented as F. That's why your value to represent in hexadecimal will be 7FF, not 71515. Because your hexadecimal numbering will be like this. After 9, it will be A, B, C until F, isn't it? So this is the only representation number can be here in your 16. So you cannot have 1 4. This one is 5 1 5 and etc. So all of this you need to convert to your hexadecimal. This is your answer. So again, as mentioned previously, please try to play around with this number and then try to play all the conversion. So there is another example for your conversion to hexadecimal. You can see over here, I don't have calculator. Basically, the most important is the step. As long as you know the step, this one you can divide by yourself, and the step if whether it have reminder or not. And over here, if you don't have reminder, what will be look like and so on. Is it have reminder or not over here? And you will get the answer like this. Over here you have reminder of 10. This one you have reminder of 7. And you will get 5A7 instead of 10. 10 will be represent as A. So please try to play around with this. Kenapa dia dekat bawah ni? Okay, please try play around with numbers because I don't have calculator. I just show you the method, and with your friend, please try also different value and you convert it. Now, is it okay or not? Any question for successive division? That is the positive number, but when you play around with the fraction number, it's going to be different. It is only apply for situation when you want to convert your decimal to any base number. But if you still remember, when you do the conversions of any base number to decimal, you will only apply one method, which is you using the multiplication. But for the conversion from decimal to any base, you need to use successive division for the positive number. But after your fraction number, this one is nombor bulat. After your fraction number, you need to use the multiplication repetition. So there is two way. If let's say you have, okay, this kind of number, I give you example, okay. 7.2 decimal. You want to convert to, let's say, binary. What is value? So you need to do two steps. First, this one you're going to use the division using the successive division, right? And this part, if you want to convert, you need to use the repetition multiplication. So this another one step, this another one step. So it's like quite complex when you want to convert a fraction number with to another pass. So the repetitions, multiplication, please make sure you know what is the function. You first you're going to multiply the fraction number by base of required numbering system, and then separate the whole part of the answer and the fraction. And lastly, repeat the step 1 with the fraction, new fraction. Stop when the answer multiplication is 0 until reach the desired fraction point. Okay. All of this, what is the meaning? As mentioned, I'm not the type of reading the sentences. I rather see the example directly I'm going to apply. So if you have a fraction number only over here, so you're going to see that you bye. Mama tengah kelas. Okay, if you're going to see over here, you will have 0.3125. Pergi tengok kucing kat luar. Abang main kucing. Abang masuk dalam mesin kucing. You will use another different method which is called as a repetitive multiplication. You will have 0.3125 times with 2. Why 2? Because you want to convert to base 2 or binary. So after you multiply, you will get the value of this one. Of course, I don't know the value because I don't have calculator. You need to multiply it, and I'm too lazy to manually multiply. And after you get this value, you will bring it to below part and you will do repetition multiplication. For your successive division just now, what you need to do is you will repeat the division, but for the fraction number you will repeat the multiplication. So you can see you will repeat the multiplication and you will get the answer. So you will repeat until you will get 0 value for the fraction. And there is no more. If let's say you can see over here until 0.5, you times with 2, you will get 1.0. So you no need for you to repeat like 1 times 2 because it's going to be similar things, and then 1 times 2 and so on. The one that you need also to bring down here is not the in front, but instead the fraction number part. So that's why you can see when you repeat the multiplication, you will reach 1.0, and then of course you're going to get 0 multiplied with 2, you will get also 0. So no need for you to do that. And where is your answer? Your answer is this part. So this is the answer for your fraction. Is it from here to here or from up to down? So this is also another different method. So you're going to see your answer will be from up to down, which is vice versa from your successive division. So this is your answer for base 2. Okay, let's say the example you have 2 point, this one, 3125. Base 10, you want to convert to binary. So what you need to do, you need to do separate things, which is this one, you will do the multiplication, and this one, you will do the division, which is 2. You will get 1. This one, 2, no need for you to divide anymore. And there is no reminder. That's why your answer will be 1042. So what you get is 10. You cannot include this to your fraction over here. So if you have the in front number over here, you need to do successive division, and your right side after your fraction, you will use the repetition multiplication. So there is two steps if you have this kind of number. So like this, you will like also convert this with the successive division. You will get 1, and then 1. Remainder will be 1. You cannot multiply again. So your answer will be 1, 1. And etc. And this part for repetition multiplication is just easy, but you need to take the answer after your fraction. The fraction only you will bring forward, and then you will multiply with the similar base, the one that you want to convert to. Now you have another example. You're going to do similar thing, only what is the difference? The difference is on your base. If you want to convert to 16, you're going to multiply with 16. If you want to have 8, you're going to multiply it 8. Okay, let's take a look over here. Sometimes you will not get 0. It will like continuously. So doctor, when you going to stop? So normally in your question, either the answer will be reach 0, or in the question it's already stated 4 fraction only, let's say. So 4 fraction point only. So you're going to stop until 4. If it's mentioned 5, you need to continue until 5. It's depend on the question. So no need for you to worry if there will be a continuous value with the fraction, because we're going to give you a stop. Okay, this one. If you have 0.798 base 10, how you going to convert it? You're going to convert using the repetition method, repetition multiplication, then you will get this value. The one that you need to bring is this one. And then you multiply again, you will get this value. You will bring downward again, you repeat is similar. It will continue. If you continue also, the fraction number also will continue grow small, and so on, and it's not going to stop. And you will only stop when you reach the desired fraction point. If let's say it's mentioned 4 fraction numbers, so you stop until 4. Okay, over here, this is your answer. And your answer will be from above to down. And again, please check this value. This value for hexadecimal, it is not found. You cannot have 12. You cannot have 1. You cannot have 12 in your uh, hexadecimal. Instead of 12, you need to convert to the symbols, which is C. So that's why you will get CC49 for the representation. And don't forget to put this fraction, because this one is fraction. So you can see you have 4 fraction point. If it asks for you to have only 3, so you only stop until here. If you were asked to only until 2 fraction number, you will only go for 0.cc. So is it okay? So this is the way for you to convert, and there is two way. As mentioned, successive division and also successive multiplication for you to convert any decimal number to any base. To any base, you're going to use two method. First, for your whole number, and the successive multiplication for your fraction number. If you have both numbering for the whole and fraction, you need to do two method. So your step will be like quite long. So there is exercise, of course, in your module, in your notes later on that I'm going to share. Please try to do and please play around with the value. Normally, we will like follow the example or follow exercise, and we will also play around and change the value only to be put into your test and also your final exam. Of course, your final exam will not cover directly module 1, module 2, because your final will only cover module 7 and above, I think so. Or maybe 6 and above. But if you don't have this basic, still in final exam, if there is a similar question, you're going to have like trouble for you to answer. Okay, now there is example. You can see you have this whole number and also a fraction number. You need to convert to your hexadecimal. And because of this, you need to do two methods. First is your successive division for your whole part and your successive multiplication for your fraction part. So please try to do it. So this is the method which is we already discussed several times, how you're going to do the successive division for the whole part. It's very easy as long as you know the method, and please make sure particular check the numbering also. And the successive multiplication also, you need to check the numbering. You're going to see how you're going to convert. You can see if it is 14, you cannot have in your hexadecimal, then you need to convert to the symbols of E. And 15, you're going to change this into F. So any question? Any question until?
I have a question, madam.
Okay.
On the left,
Okay, on the left.
we stopped at 5, right?
Because you cannot divide 5 with 16.
Yeah.
Because it is smaller than 16.
All right. Because yeah, I sometimes get confused, So I just wanted to make sure.
Okay, if let's say you have 8 over here because you want to convert to octal, the value is 5, then you need to stop also because it's smaller. You cannot divide it anymore. But if let's say you need to convert to binary, you have 5, then you need to continue because 5 can also still can divide with 2, which is you're going to get 2. And then you're going to continue again because 2 also can be divided until you get 1, right? So it's depend on the number that you want to change for the divisions over here. Okay, then you're going to see whether you can divide or not. You're
All
going
right, I understand.
Okay, you're going to stop until it cannot divide anymore. And of course, you're going to have the reminder. Okay, so any other question?
I have a tip for using the calculator.
Tips. Okay.
What?
No.
Yeah, it's a
Mm.
tip. So to find the remainder, let's say, for example, we need to divide 1447 on 16.
Mm.
Okay, so we'll get the answer 90, and there's a point and
Maybe
some
you
other
can
numbers.
like pointing
Share
up
the screen.
yeah,
All
and
right,
pointing
so
up your calculator to your friends.
yeah, all right, 1 second. Uh, all right, do you see the screen now?
Not yet. Okay, now it's okay.
All right, let's say 1447. All right, so we divide it by 16. So we get this value, okay? To find the remainder, we take this and we multiply it by the same number that we divided on. So we multiplied with 16. So the remainder is 7. So when we divide 1447 on 16, we get 90 and the remainder is 7. This is just a simple way to find the remainder if we're using the calculator on large numbers.
Okay, thank you, Abdul Kadir, for your sharing. So I hope that is going to benefit to your friend also about finding the reminder. I also didn't familiar using calculator. I think yeah, because it's already too long for me to use calculator, so I forgot already. Maybe I also don't know.
Yeah, but it's hard on large numbers.
Oh.
You're gonna do this all manually, and no one
Mm.
can like divide 1447 on 16 like just like that.
Mm.
So yeah.
Okay, thank you. So, any other question? So it's good to be like Abdul Kadir, which is you in the middle. You can also share with your friend. Okay, bye.
Doctor, I have a
Yes.
question.
Mm.
What does it mean by up to 3 fractional points just now?
Okay, if up to 3, you're going to have 3 point after your fraction only. So you're going to be like 0.111. Then 3 numbers after your fraction, you're going to stop. If you have like 4 fraction numbers, four fraction value, what is called? Uh, 4 fraction point, then you're going to have after your fraction, which is after your point, you're going to have 4. If let's say 5, then you have 5 numbers after your point. This one. So this is your desired fraction point. If let's say it's mentioned 4, then you will have 1, 2, 3, 4. If 5, you're going to have 1, 2, 3, 4, 5. If let's say 3, you're going to have 1, 2, 3 only. 2, which is CC, and then 1 will be C only. one fraction number. Okay.
Okay, understand. Thank you, Doctor.
Okay. Thank you too for asking. Okay. Any other question? Let me check first. It's good for you to like have um, sharing session rather than learning session. Learning session is you only learn, you did not respond. So you're going to feel boring. I can read several of your. I can see just now I read this one. Siapa Fang? Is it Fang? I forgot. Where is the person? Just now I read. Fang. He mentioned that he loved talkative, but in class, where are you? And then you need you love like to cheer a situation. You love to have like joyful environments, but in class, why don't all of you try to apply this environment, which is you're going to have fun in class learning? So just interrupt me. If let's say I draw like very ugly, you can just open your mic, doctor, why it's too ugly? Just to make the situation like alive, and your friend will be laugh also while learning. Is it okay or not? Maybe in next class you can like just saying anything like the one that your friend also mentioned, can we have take a break and so on. So just say anything that you want to do. Okay. Or maybe in whatever you have something in mind, just say and share with us. Or maybe in our class suddenly you got very funny WhatsApp from your friend, maybe you can just interrupt. Doctor, I want to share something. I got this very funny WhatsApp. Although it is not like and having any relationship between your class, which is learning, but still you can uh, have something to make this session live and funny, and then your friend also will like, okay, I have a break with the one particular funny story from your friend. So it's okay to have that. I guess this another subtopic I'm going to continue in our next class. And as promised, I still not yet share the video for our module 1, the last part, which is about marks, demarks, IC, and so on. So I will keep my promise. I'm going to share as soon as possible. But today I have class until 4 again today, back to back. Maybe tomorrow I'm going to record the video for that particular subtopic. Then next, after next class, which is next week, we going to like have a revision back, and then we will discuss in class. If any question, you can just ask me, and we will continue with this binary to octal hexa conversion. Okay. So any other question? If there is no more question, please make sure you already scan your attendance. There is another 2 student not yet scan the QR code, and we will end our class session now. Please stay safe at home and have a very beautiful day for today. Okay. Bye
You too,
bye.
doctor.
Thank you, doctor. Bye
Thank
bye.
you,
Thank
doctor.
you, doctor.
Thank
Bye.
you,
Thank you,
doctor.
doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, doctor.